And sometimes the strategies that we learned in permutations, we also use in combinations. For example, in this one, there are two major decisions that need to be made. You have to decide which cashiers you're going to hire, and then you have to decide which clerks you're going to hire. What officially does a clerk do? Is that someone who like stocks shelves?
I assume.
It's like, is that a weird word? It feels weird to me.
I think it's just someone who works there.
Just someone who works there? Is it a verb? Like, do clerks clerk?
I mean, do cashiers cashier?
It's a good question. I don't know. So we have to decide two decisions. We have to decide who we're going to hire as our cashiers and who we're going to hire as the clerks. And then in your decisions, you put how many choices you have. But our choices is a combinations question. Because 7 applicants for cashier, you choose 3 of them. Does the order matter? No. 7, choose 3. Clerks. Does the order matter? Nope. So 8, choose 4. Sometimes I've seen on exams where it's non-calculator and they write the answers like this. Can you see what I did? 7, choose 3. Can you do it now? You see this? Can you do it mental math? What number is it? You want me to write it down because you're afraid to say it out loud? Can you do the mental math just on this one? You get 35?
Yep.
Right, expand the bigger one until you can cancel out. And then 3 factorial is 6, which cancels out with the 6. Everything's shown here. You go 7, 6, 5, 4, and you're like, ooh, there's a 4 on the bottom. I can cancel those out. And then 3 factorial happens to be 6, which is like, oh, that cancels out. And you get 35. Okay. So this one has decisions, but the choices in the decisions were combinations, not permutations. Okay, questions for practice on this? 12, 13, 14. We're going to do sum of 15 together. And 16, yes. The most typical one of these ones that you'll get is A, and on a test, A would say to solve it algebraically. So anytime something says solve it algebraically, you have to use the formula. So this would be n factorial, 2 factorial. What else would be here without looking at your formula? N minus 2, because those 2 still have to add up to the top one. And it's equal to 28. So we're going to need to simplify. Here's the factorials. We need to simplify them. Are you okay if I move that 2 factorials 2 to the other side? I'm multiplying both sides by 2 to get 56. Then to simplify factorials, we always expand the bigger one. Which is bigger, n or n minus 2? N.
So you take
N. And then one last would be n minus 1. Then one last would be n minus 2. And you're like, oh, I could keep on going, but I don't need to, because that would cancel out nicely with the n minus 2 on the bottom.
So then become n squared minus n.
And then we get a quadratic n squared minus n. Move the 56 over equals 0. We could factor n minus 8, n minus 7, and so you get, or n plus 7, sorry. So you get n is equal to 8, and n is equal to negative 7. But you do have to check with factorials, because you can't do negative factorials. So this one's extraneous. and 8 is the only answer. So we will have some, most typical are ones like 8. Okay? The other ones, 4 choose R. Does it make sense that R has to be less? Right? It's like you come to your prize table, there's 4 prizes, choose 7 of them. And the person is like, what are you talking about? 4 choose 7 doesn't make sense. Because you can't have 4 things and choose 7 of them. So for this, is it 4 choose 1? No. Because 4 choose 1 is 4. Which means you also know it can't be 4 choose 3. Because that's 4. So it's probably going to be 4 choose 2, and you're right. And guessing and checking for these ones, for C and for D, there's not very many you have to check. In fact, if you think about it, if you check 1, 6 choose 1 is 6. You've also checked 6 choose 5. So then you do 6 choose 2. Do the math around 6 choose 2. You get 15. Doesn't work. Which means you also tried 6 choose 4. And then all that's left is 6 choose 3, and sure enough, it's 12. So we have these ones where you're picking this number. You're not going to use the formula for that. There's not too many to try before you can figure it out. Okay? But then ones like B, we're going to sort of use a mix of algebra and not algebra at the same time. Okay? I'm going to tell you what full algebra would mean, and you'll be like, yeah, I don't want to do that. And then I'll show you ways to do it otherwise. So n choose 4 would be n factorial over 4 factorial, and what would be left? N minus 4 factorial equals 35. 4 factorial is 24. I'm going to simplify my factorials. Are you okay if I move the 24 to the other side? Are you also okay if I'm lazy and I just leave it as 35 times 24? This is going to be beneficial in a little bit. I think it's 840 if you really want to know. Now, which one's bigger? N or n minus 4? Well, n is bigger, so we start expanding the bigger one. 1 less would be n minus 1. 1 less would be n minus 2. 1 less would be n minus 3. 1 less would be n minus 4. And finally, we catch up to the one that's on the bottom to simplify. If you were going to solve this algebraically, you would next, what did we do here? We multiplied out the n times n minus 1. Does that not look like fun here? Do you see that you would get an n to the 4 and a whole bunch of other stuff? Then you would have to move the 840 back to this side to make it equal to 0, and you would have to factor your n minus 4 equation using everything we learned in chapter 1 with the factor theorem, remainder theorem, and synthetic division.
Yeah, no thank you.
And 840 is, not too small of a number. It could be plus or minus 1 and plus or minus 840. 2 and 420. 3 and, oh my goodness. There's a lot of them that you'd have to check before you could get them right. So, here is a secondary way of looking at this. We look for a little bit of a pattern. I notice on the left that I have 1, 2, 3, 4 factors multiplied by each other. I also notice that they are consecutive. They're going down by 1 each time. So now I'm going to just play around with this side. I've got 2 numbers multiplied. Could you break it up to be 4 numbers?
Yeah.
Yes. What could you break 35 up to be? 7 and 5. Now, you could do 12 and 2, 8 and 3, or 6 and 4. But my strategy that I noticed on this side is they should all be consecutive. So how should I break up 24? 6 and 4. Because then I could think, hey, this is the same as 7 times 6 times 5 times 4. And this was n, so n has to be the 7. It's not guessing and checking. Guessing and checking was like, oh, Is it 17? Let me check. No, it doesn't work. Is it 3.1? No, it doesn't work. We are using some logic here, but the algebra would take forever. So you will get some questions like that where this logic strategy might be really, really helpful.
Will be helpful.
And quicker.